Well, good afternoon, viewers. Today we have a 2006 Toyota Rav4, and it's here because the money light is on. Let's get in the cab and shut this door so we get rid of this annoying chime. It's got a number of warning messages and lights on. Check engine light is on. Low fuel light is on. Why is the low fuel light on? I think he said there was a problem with the fuel level sender. Four-wheel drive light is lit up, and the VSC, vehicle stability control, message is there. So we're going to scan this thing and get some direction. I think he's had it at the dealer and they were chasing an EVAP problem, but the EVAP problem shouldn't theoretically affect the fuel gauge. I wonder how much gas is actually in the tank. Well, we'll be able to tell when we lift it up and look at it with a thermal camera. So let's put the scanner on it and get some codes out of this thing to start with. So this is another new vehicle record today. I've never scanned this before. Customer was a referral from another customer. It's got 199,900 kilometers on it. Roughly, give or take 100K. Let's do a code scan of all controllers. I do have it running and that should be okay. Pressure sensor low input, so that's an electrical fault. P0452. Of course, that SureTrack is suggesting a gas cap or EVAP canister. I think they said they put the EVAP canister on it. Engine, transmission are all setting the same code. Anti-lock brakes is complaining about the code in the engine control computer. Four-wheel drive is complaining about the code in the engine control computer. Seems odd that we'd have a problem with the fuel gauge and the fuel tank pressure sensor. I wonder where they live. Maybe it's related. Maybe we have an open ground or something like that for the... Let's go into the engine control computer and have a look at some data. Don't need to look at freeze frame data in my opinion because the problem's there right now. So let's look at VVT and EVAP and AC data. So I'm going to look around for the important data parameters here. So I couldn't find the actual fuel pressure or fuel tank pressure in as a voltage, because I'm sure it produces a voltage, the sensor, but I do see the calculated value based on the voltage, and it's way out, 495 millimeters of mercury. This one says absolute at 266 millimeters of mercury. So this is millimeters of mercury gauge, and vapor pressure millimeters of mercury is 492. So that's like negative 10 psi. If I ask Google to convert millimeters of mercury to inches of psi, it's roughly 266 is roughly 5 psi. So there's a problem with the sensor, but I'm going to look at the electrical diagram to see if the fuel gauge and the fuel tank pressure sensor share anything in common, like the 5-volt reference or the ground, more likely the ground. Let's look at a wiring diagram. So here's the troublemaker chart from Toyota regarding P0452. On one page it says the code is the same as P0451. So, but if we look at P0452, it says canister pressure sensor low input. EVAP pressure less than 42 kilopascals. for 0.5 seconds, and the possible causes are the canister pump module, connector wire harness, canister pump module, EVAP system hose pipe from air inlet port to canister, and ECM. This is not any help at all. And it's in the other page it said it was the same as code 451. I understand why technicians throw parts at stuff. You know, it's probably the canister. Let's change that. And I think that's been done and taken off. So I'm going to look at the fuel gauge. There's no cases on Identifix for the P0452, which strikes me as odd. But let's look at fuel gauge inoperative. I still think both problems are related. I have a gut feeling. They spell gauge with a U or without a U? American. Fuel gauge is an operator. Fuel level sensor, combination meter, SK1 connector. That's an interesting. These are confirmed fixes. SK1 connector. Use the scan tool in the meter ECU to look at the data. The fuel input will go from fuel level near zero, empty at 255 counts. Use the active test to see if the gauge can be moved. SK1 connector. Let's look at this case. Check the voltage of the yellow wire at the fuel tank. It should read 5 volts. With the fuel sending unit disconnected. If there is no 5 volts, check the SK1 connector before the center console. It can be contaminated with spills from the cup holder. Isn't that special? Well, let's look at the wiring diagram to see if there's a relationship between this fuel level problem and the pressure sensor problem. So here's the Mitchell version of the fuel level sender circuit, and it shows a junction block behind the center of the dash, but it doesn't show that SK1 connector, and I think it'd be in this location here. But that's typical of Mitchell. They leave out some connectors and they just show some of the components. So I did look briefly at an OE diagram, and it did show the junction block and 2 connectors, but it doesn't show what else. There's a splice coming off of here, and I'd be curious as to whether or not the fuel tank pressure sensor utilizes that too. But that's in a different wiring diagram. So I'm going to print this diagram, or try to print it, so that we can refer back to it. Got to gather information from multiple sources. Let's see if this, yeah, that looks pretty good. So let's print this. And let's go back and look at powertrain management. It might be under ECM for engine controls. Okay, where is it? Computer data lines, body computer, immobilizer, door locks. Let's close this diagram. Starting charging warning. Where's the engine controls? Am I blind here? What's going on? Let me look around. So I can't see engine controls or powertrain management anywhere in here. Power distribution, power windows, power tops, exterior lights, electronic power steering. All right, well, we'll go into the OE diagrams then and look for it in there. It's not clicking, it's not going back. Let's look at motor wiring diagrams, which is OE version copied. The hyperlinks don't work on these diagrams anyways. At least with the motor tab, we get an index of a list of circuit diagrams. I'll wait for this to load. So here is the list of engine control diagrams. Would it be under fuel? I would think so. EFI relay, fuel pump relay, fuel injectors, fuel VSC, air fuel ratio sensor. Well, let's try the first one. Lovely. So there is the fuel pump resistor, fuel pump relay. This has a two-stage fuel pump, runs it through a resistor most of the time and bypasses the resistor during cranking. But that doesn't show the fuel tank pressure sensor on there, at least I don't see it. But we might as well print this diagram too, because can't have multiple diagrams open conveniently at the same time. So I'm back looking at the P0452 code, and here's a diagram showing the canister pressure sensor, and it's actually in the canister. Now it shows pin 2 being a ground. It doesn't give the wire colors, thanks Toyota. Pin 2, 3, and 4, and the canister has a leak detection pump in it, a little vacuum pump in it. I'm looking underneath the vehicle. Have a look underneath here. And I can see that the charcoal canister has been off. The bolts have been, the fasteners have been removed. This looks to be the connector here. And I noticed the wiring harness goes into the console, under the console. And I have it in the back of my mind about that potential connector compromised because of spillage from the console. So I think it'd be a wise decision to go in there and look for that SK1, I think it was. So I'm looking through the schematics here and trying to find that connector SK1, and I see this picture showing the fuel gauge wire harness coming from underneath the driver's seat, and it goes into the console area. But I don't see SK1. JK1. K1, but not SK1. KX1, LY1. I wonder if there's a connector view so I know what it at least looks like, and maybe a connector pinout so I could see if there's any relationship between the two circuits that are malfunctioning. Oh, there it is, SK1. It's right under the middle of the console. Right under the middle of the console. So I wonder if we can get at that. I looked briefly at the inside of the cab and it looks pretty clean. The customer's pretty neat by the looks of it. I don't see any lots of spilled coffee or pop or juice or anything like that, but anything's possible. I'm gonna see if I can find a connector view. So there's what SK1 looks like. It's a 6-pin connector. Considering the fuel gauge and the fuel tank pressure sensor and EVAP system, it'd be nice if I had a pinout for this connector, SK1. So I started removing the console. There's 2 screws in the bottom underneath the mat, and then that power plug comes out, just pops out. And I'm looking down in here and I can see some copper, some chewed wires. There's that SK1 connector. Let me get the light here. I got a light on my headlight on my forehead, but it doesn't work good for the camera. Okay, can you see the copper down there? So some rodents have been in here chewing on wires. Well, let's get this apart. So there's a look at the damage. There's chewed wires here. Definitely rodent activity. That's that SK1 connector, the white one right there. But there's several broken wires here, so I'm going to disconnect the battery because there could be live wires here. Theoretically, this would be a insurance repair, but I'd probably have a $500 deductible, so let's see just how bad this is. I might have to take the shifter out. I found a really good, excellent video on how to remove this console. I'm going to link to it in my description. It's very professionally made and helped me out in getting this console off. If you don't know how to release the plastic pins and clips and all of this plastic trim, you'll break stuff. So there are several broken wires here. This yellow wire is broken on this connector, and this brown wire is broken completely on this connector, and then there's a bunch of them compromised. I'm not sure which is which, but I'm sure this is the trouble, because this is the fuel gauge wiring, I believe, this connector. I'm going to take the parking brake off the floor so that I can pull the harness out a little bit more to get it up and work at it. See if we can't fix these terminals. So I got my cat in here doing a CAT scan, checking for mice. Anyways, I got the wires repaired. I bypassed the connector on 2 of the wires because they were eaten off right at the terminal. And yeah, we're going to reconnect the battery and see if everything works again. So I'm going to turn the key on, and the fuel gauge reads full. I don't know if the tank's full. Well, I got it back together again. I'm going to put the console in. Maybe I'm going to start it and check the data parameters before I put this console back in. Yeah, that's a good idea. So we're going to check codes, current codes. Hey, no current codes, but we'll have the history code. No, got no history code. Oh, because I had the battery disconnected, that's why. Let's look at some data. Fuel tank pressure or EVAP pressure sensor readings. See if they're near 0 now. That's gauge pressure. Vapor pressure, 736 millimeters of mercury absolute. Where's gauge? Yeah, there we go. 3.905 kilopascals. Well, I'm sure it's going to be fine, so I'm going to put the console back together now. Well, there it is, all back together. No warning lights on except the door ajar and the seatbelt reminder. I cleared all the codes from all the controllers. So I think this thing, I don't know if it's going to pass an EVAP test, and it's got too much fuel in the tank to run an EVAP test. So I'm going to give it back to the customer with the understanding that if the check engine light comes back on, it may have some issues with the evaporative emission system, but I can't run an EVAP test now with it at 98% fuel level. So that's it. Thanks for watching. So I figured I'd try and run the automatic system EVAP check anyways, considering that the fuel tank is around 95%. Says the system will simulate system monitor. If a malfunction detected, DTCs will set. To prevent damage to the system, scan tool will automatically stop the vacuum pump when pressure drops to negative 39.8 millimeters of mercury. Continue. Ensure the following conditions: vehicles in park, ignition is on, engine not running, fuel temperature below 95, fuel level must be between 1/2 and 9/10. Key off for 10 seconds and do not apply the brake. So I'm going to turn the key off. Okay, so I cycle the key off for 10 seconds. The key on, do not start the engine, do not apply the brake. Graphic display. Can only be activated every key cycle. If test completed already, exit and restart the test after cycling the key on and off. Simulate the system monitor. If a malfunction is detected, a DTC will set. Begin automatic test. Test will last 8 to 20 minutes. It's one way to increase the billable hours in the service department. Please wait for 10 seconds. Hurry up and wait. Oh, how cool. It's got a little countdown timer in the bottom right corner. Well, let's let it run through this test. It's checking static pressure, I think. Please wait. I guess they should have said put a battery charger on it. I'll keep an eye on the battery voltage. It's 12.3. So I hear a little pump running, vacuum pump running. That's a good sign. I'm not sure if it would abort the test if the fuel level is too high or not. My little vacuum pump is still running. I can hear it, and it says on right here. The vent solenoid is energized. Looks like it's doing it multiple times. Pumps off. Leak was completed. Continue. Check and display of codes, if any. Current codes. No codes. Well, that's a good sign. Well, I'm still going to tell the customer that it's got to go through normal drive cycles to be sure that it's going to run and pass, because sometimes the manual test will pass and yet will still fail in real life. And it's probably not going to be a problem now because it's getting cold in the wintertime here and it's below freezing, so it won't run the test if it's below freezing. And if it won't run the test, it won't fail the test. If it won't fail the test, it won't turn on the MIL. So we're probably good till April or May. That's it. Thanks for watching.